Hi, Pre-Calc. This is Miss Jensen. We're looking at section 2.5, which is finding determinants, something called determinants, and the inverses of matrices. So we need determinants in order to find the inverse of matrices. We need to find the inverse of matrices because we use it to solve systems of equations with matrices. So kind of right now, we're looking at solving systems of equations algebraically. This is the prerequisite for solving systems using matrices. So if you think about what an inverse is, inverse is just in the case of an additive inverse, it's what you add to a number to give you 0. Well, the opposite of 5 is -5. So the inverse of 5 is -5 because when we add them together, we get 0. For multiplicative inverse, it's what do we multiply a number by to give us 1. So 9 times 1/9 is 1. 4/5 times 5/4 equals 1. So it's just the reciprocal. What we're doing when we're finding the inverse of matrices is we're really finding the multiplicative inverse. Just going to erase this. I didn't mean to have that up there. Determinants. So if we look at these matrices here, this is a regular matrix. Notice that it has these little corners here. We can either ask for the determinant by going det of a matrix, determinant of a matrix, or instead of saying det, you can just have those straight lines. It almost looks like absolute value lines. That also means find the determinant of the matrix. And notice the notation here. It's just taking a sub 1 times b sub 2, kind of this downward slant, and we're going to minus the product of the upward slant. Down minus up. So if I look at this example here, the downs are 2 times 7. So we'll go 2 times 7. And the ups are -4 times 3. And we're going to take the answers to those and we're going to subtract them, because notice there's a little minus sign in between there. So we're going to subtract them. So 2 times 7 is 14. -4 times +3 is -12. And now this is equal to 14 minus a negative, which is the same as a plus. 14 plus 12 is 26. That is the determinant of this matrix. So again, we need the determinant in order to help us find the inverse. Okay. So multiplicative inverse of a matrix. So if you kind of look here, the first thing it's saying is that if we find the determinant, if we go downs minus ups, AD minus CB, or BC, and we end up with 0, we're going to end up without a matrix. And the reason is because part of finding the inverse is putting 1 over the determinant. And remember how a determinant cannot have 0 in the denominator. So this is kind of saying we can't have 0 in the denominator, and if we do, then we're going to say there is no inverse. Okay, so we'll try a couple examples of those. So again, the inverse, and this is a to the -1, just like 5 to the -5 is the same as 1 over 5. This symbolizes also the inverse. Anything to the -1 is the inverse. So it's 1 over the determinant, and then notice compared to the original how this diagonal is just switched around. This diagonal stays the same. Like this is BC, this is just the opposite of B, opposite of C. So we're going to find the inverse of this. I'm going to start with the downs. So I'm going to go 5 times 4. So this is the determinant. And we're going to multiply it times the ups. Oops, I don't know why I did that. Made it a 40 there. I'm going to do it minus the ups. 6 times 3. And we're going to subtract it. So we end up with 20 minus 18 is 2. So that determinant goes in the denominator, and there's a 1 on the top. Okay, so the 2 goes in the denominator. Now for the rest of it, I'm going to start with this diagonal. The 5 and the 4 just switch places. This becomes 4. This becomes 5. The other diagonal, the 3 and the 6, they stay in the same spot, but this just becomes -3. This becomes -6. Okay, so we're just doing the opposite. And we can leave the determinant like this. I also could take the 1/2 and multiply it throughout if I wanted to. And that's actually the way it would come up on a calculator. If you did the inverse in your calculator, your final answer would be 2, -1.5, -3, and 2.5. But you can just leave it like that without it being multiplied out. All right, let's try another one. So we're going to start by downs. This is 3 times 4. And we're going to do the ups. -2 times -6. Maybe you can see already what's going to happen here is we end up with 12 minus 12, because -2 times -6 is positive 12, and 12 minus 12 is 0. So in this case, we're going to say there is no determinant. It doesn't exist. You can even say does not exist. Oh, not an F there. It does not exist. Or if you would want to do this, or just say, you can say the whole sentence does not exist. All right, so this is just about it. Maybe we'll try one more example here, and then I think should be off and running. So once again, same thing we were looking at before. We'll do downs here. So 0 times -9. 0 times -9 is obviously 0. If we go the other diagonal, 5 times 4, well, 5 times 4 is obviously 20. And so if we subtract those, we end up with 0 minus 20 is -20. So that's the determinant. Maybe I'll just write this on the side here, determinant, DET. All right, so this is kind of what you're always going to get for the determinant, 1 over, or pardon me, the inverse. Just getting it all set up. We're going to take that -20. The determinant goes in the denominator. We will take this diagonal and we'll switch them. So instead of 0, -9, it's -9, 0. And finally, the last one that stays in place, except it's the opposite. So instead of +4, -4. Instead of +5, it's going to be -5. And that's it. Okay, again, I could take that 1/20th and multiply it times all of it, but I wouldn't have to. You can just leave it like that for your homework today. All right. One more example. What the heck? So I'm going to set it up ahead of time. I'll put 1 over. So again, downs. So this becomes negative 14. Ups is 35. And if we subtract the two, negative 14 minus 35 is negative 49. So this becomes negative 49. And now a little rearranging. Switch places there. This is 7. This is a negative 2. These two just become the opposite. Instead of positive 7, it's a negative 7. Instead of positive 5, negative 5. And that is the inverse. All right. So that's pretty much it for today. Your worksheet is going to be the 2.5 worksheet where you're, there's some just review problems from matrix operations, but then some where you're finding the determinant and the inverse. So this is kind of a prerequisite for what is coming up next. There's no test, and yeah, this is new. Don't worry about that. We're going to do one test in the end here. But this is a prerequisite for what we're doing next, which is solving systems using matrices. That's all for now. Have a great day.